Welcome everyone. In this session, we are going to talk about LLMs, short for Large Language Models. You may have heard about these models powering modern chatbots, translating languages with impressive accuracies, etc. But what exactly is an LLM? And why is it called large? This is something that we'll be exploring in today's video. We'll look into what an LLM is, how it fits into the family of AI models, why it is called large and what role data or parameters play in calling it large, how LLMs can, solve different tasks like summarizing text, answering questions, or even composing new articles. If you have been following along with our earlier discussions about neural networks, deep learning, etc., this is the perfect next step. We have talked about neural networks that are digital webs of artificial neurons that learn patterns in data. We have also seen that deep learning involves stacking many of these layers of neurons to tackle complex tasks. A large language model or an LLM is a specialized type of deep neural network. It focuses on natural language. That is, the words, sentences, paragraphs that we use to communicate every day. You can think about it as a language expert in the AI toolbox. The large in a large language model comes from two main factors. The first one is the presence of billions of parameters. A parameter, which is often referred to as the model weight, is the internal numbers that get adjusted during training. While a small neural network may have thousands or millions of these model parameters, a large language model can have billions or even hundreds of billions of these parameters. This huge capacity allows them to capture very nuanced language patterns. The second factor is the huge amounts of data. LLMs are trained on massive text datasets. Everything from books and news articles to social media feeds, posts, etc. The idea is to expose the model to as much natural language as possible so that it can learn patterns like grammar, etc. It is also able to copy the writing style. Most of these large language models are built using something called a transformer architecture. In a transformer, you provide the model with some text, like a question, a sentence, or a paragraph. A transformer has something called attention. This attention mechanism pays attention to all the words in the sentence, figuring out how each word relates to all other words. This helps the transformer model to handle context much better. The model produces predictions for what the next word should be, what word should come the next. Over time, as it learns from large amounts of data, it can figure out what the next word should be in such an amazing way that it sounds like a sentence that a human would say. This training usually involves a task called next word prediction. So sometimes these words or subwords are also called tokens. So the training process usually involves predicting what the next word should be or the next token should be. The model repeatedly guesses what the next piece of text is supposed to be, and in the process of making those guesses during training, it adjusts the billions of model parameters that it has internally. Because LLMs learn the general patterns of a given language, they can be adopted to solve different things. Like, for example, text completion, where you are predicting what the next word should be, or answering questions, or being able to translate, or being able to summarize, or even chatting with you. Under the hood, they are all still math and numbers. You may have come across many chat-based LLMs that can talk to you like a human. They can hold a conversation with you almost like how a human would do. They can even assist you with coding tasks. These models have been exposed to such large amounts of text that it can often look like it's being intelligent or creative. These are often optimized or fine-tuned versions of a general large language model. So there's something called a base model. The base model is the large general purpose LLM that is trained on a broad range of text. It already has a substantial grasp of grammar, sentence formation, some general knowledge, etc. from its training data. A chat LLM is something that is, fine-tuned or instruct-tuned on dialogue-specific data. It often has additional steps like reinforcement learning with human feedback. It's also called RLHF. This makes the model better at handling back and forth conversations. So it can follow the prompts closely and it can provide contextually relevant answers, especially in like a chat format. Similarly, some LLMs are fine-tuned on large datasets of code from public repositories. This allows them to assist with coding tasks like code completion, debugging, or suggesting like entire functions or chunks of code. These models have learned coding patterns. They have learned about syntax, best practices, etc., just like how general LLMs learn natural language. This enables them to provide targeted help for software development. So a question that usually comes up here is, what if I want an LLM that is optimized for my specific task? Like, for example, a customer service LLM that knows everything about my product, right? It knows everything about my user manuals, and it'll only answer questions about my product, not general things like, how to bake a cake or something like that. In this case, do I need to train a separate large language model to accomplish something like this? So you don't necessarily need to do this. However, we'll cover this topic in an upcoming video, which talks about how you can create solutions for your particular problem, starting with a general purpose LLM. So we are going to skip that part and talk about large language models. So are all language models the same? Well, not exactly. Many LLMs rely on the same basic architecture called the transformer. However, they can differ in how these transformer blocks are arranged internally, resulting in different model architectures. Even though all of these models use a transformer, there are many ways that you can tweak the arrangement of them to come up with different models with different number of model parameters. There can be models with 7 billion parameters or 300 billion parameters, depending on how complex the model architecture is. A model also differs in the type of data that it is trained on. Some of them may be trained on mostly academic text, and others on diverse websites or social media posts, or on code in different languages, etc. After a general training phase, LLMs can be fine-tuned on specific tasks, like for example on legal documents or customer chats, etc., to improve their performance on a much narrower domain. All these factors play a role in creating a variety of these LLM models. Each of these is suitable for solving a different type of problem. So in summary, an LLM is a deep neural network specialized for language tasks. It's labeled large because of the massive amounts of data and the huge number of parameters it involves. It is built upon an architecture called transformers, which has an attention mechanism that helps it to handle context really well. It can accomplish impressive things like translating languages, summarizing, chatting with you, helping you with code, etc. So essentially, large language models are giant, deep neural networks that have been fine-tuned for our written and spoken language. By training on vast amounts of text and adjusting billions of internal parameters, they have learned to predict text in a way that they can rival human performance on many tasks. They're not perfect and they're not truly thinking in the human sense, but they're a big leap forward on how machines understand and produce language. Thanks for tuning in, and I hope this gives you a good understanding of what LLMs truly are. Stay curious and see you next time.